Hello chaps and chapettes. Now today we're starting off on radioactivity and understanding ionizing radiation. And to do that we're going to start off by looking at the atomic model. Now this is something you would have covered in chemistry, but actually this is physics and it's mostly done by a physicist, and chemistry just relies on the understanding of it to do whatever it is they do. So today we're going to know what is meant by the nuclear atom. We're going to understand the other models that have been suggested over the course of history, and we're going to be able to describe how the nucleus was actually discovered. The challenge today is to discuss the implications of the atom being mostly empty space, and well, let's carry on from there. So the first thing you need to know is that the atom is made of a positive nucleus and some orbiting electrons going on the outside. So you can imagine this as being like a very, 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 very small solar system, where the nucleus is like the sun and the electrons are planets whizzing around the outside. Now this is not really the case at all, but it's a good, useful model to have inside your head. So the first thing you need to know is that the nucleus is really, really small in comparison to the actual size of the atom. Your analogies are going to vary on this one. I like to say that if the room that you're standing in is an atom, then the nucleus is basically a speck of dust within that room. And that's probably a bit too large in the first place, but you get the idea on this one. So the electrons will be whizzing around the outside of the room, and your nucleus would be a small speck of dust just sitting in the middle, held by various things. So we need to know what's inside the nucleus, because the nucleus actually contains the majority of the mass and actual stuff inside your atom. Electrons have a little bit of mass, but they're so small that they don't really have much of an impact. So the nucleus is made of neutrons and protons, and they have roughly equivalent relative atomic masses. Basically they're the same-ish size. Neutrons are a little bit more massive, as in they have a little bit extra mass. Now what you need to do is pause the video and draw the atom in front of you. The atom in front of you is a helium nucleus, helium atom, and it's the easiest one to remember in terms of revision in GCSE, because it has both neutrons and protons and also electrons whizzing around the outside, and it's the simplest one, being the second element on the periodic table. So pause the video, draw that down, and then we'll talk about the next bit and the atomic models that there have been. Hopefully you've drawn that down, and what I'm going to show you now are the other models that have existed. Going way back to the Greek times, when people just assumed that an atom, well that's not assumed actually, but people theorized and hypothesized that an atom was the smallest bit of something. As in you take a tree and it's the smallest bit inside the tree, or you take a sword and there's the smallest bit inside a sword, and they went from there on to various other types of what they called elements and things, and basically breaking things down to its basic components. And that was the idea. Now John Dalton came along a long time later and suggested that actually maybe there was these things called elements and they all had different colors. It was how he imagined it, saying that there was like an iron element, a copper element, all that kind of thing, and that has special colors and therefore features, and then if you stacked them all on top of each other like very, very, very tiny Lego, then you'd actually get the larger structures there. So that idea was developed along until this guy called J.J. Thomson came along with the plum pudding model, where we had a bunch of negatively charged electrons sitting inside what they called a field, a positively charged field. And that was called the plum pudding model because it was kind of like a pudding where you have like cakey stuff on the outside with lots of little raisins inside and lots of the plums sitting inside your pudding. And the plums being the electrons and the cakey bit being the positive bit. All these models were incorrect, and I'm going to tell you now about the Rutherford experiment, which showed the next step on this one. But still, it's not a complete model. There's going to be a little bit more that you need to learn later on when you go on to take physics at A level and chemistry at A level as well. And if you go to university, you'll find that even that's probably not the case, but it's the working model you got for now. Right, so this is the Rutherford experiment. and we're going to be firing some alpha particles, these ball bearings, towards our nucleus, this box here. Now we can't see inside the nucleus, well, we can't see inside the atom, sorry, this thing is the atom, so we can't see inside the nucleus to actually find out what it's like. So what we're going to do is we're going to fire our alpha particles through the atom, and this little ramp here is going to give us our acceleration. Now, if the plum pudding model was correct, what would happen is this positive particle would go flying towards it, and then either rebound or at least slow down a bit as it goes through the positively charged sort of plum pudding bits there. So let's have a look. And this is going to go through, straight through, without even slowing down a bit. Whoop, scrap that, there we go. So that's rather annoying, because it means that the plum pudding model is not correct. Well, not really annoying, that's exactly what we expected to see, since we now know about the nucleus model. So we're going to move this gun, or this alpha particle gun, a little bit closer towards the center and fire more towards the center. And we're going to see that it basically goes straight through again. And that's because the nucleus is really, really, really tiny. But at this point, you might be thinking that the entire experiment is wrong and there's actually nothing inside this atom here, no nucleus at all. So let's just keep bringing it closer and closer towards the center. Okay, and we've got nothing there. What I'm going to do is I'm going to slow down this a little bit, because it may be that we're going a bit too fast for us to see a reaction. So let's slow that down a bit. Boom. There we go. We've got a nice big deflection there. And that's going to be our positively charged particle rebounding away from a positively charged something in the middle. And we believe that's something to be the nucleus. Some nice deflection there. If we put this right in the center, we should... Oop, too far. Let's try that again. Okay, right in the center. There we go. Okay. And it pops straight back out at us. And that means that there's going to be some sort of positively charged object inside there. So, there we go. That's the Rutherford experiment. And this is a wonderful piece of kit, which was actually handmade by one of my lab techs. Fantastic piece of work. So, there you have it. You have now, or should now be now. So now you should know what is meant by the nuclear atom and understand that there were a lot of other models suggested for an atom. You should also be able to describe how the nucleus was actually discovered, as we had the Rutherford experiment by firing alpha particles towards our nuclei and then seeing what came out of it. So what you need to do now is make sure you can describe the journey to understanding the nucleus and say how the Rutherford experiment took place, and then challenge is to discuss the implication of the atom being mostly empty space. Tell me in the comments below what are your thoughts on that, and I will catch you in the next video. Please like, comment and subscribe. There's going to be definitely a lot of people out there that will need to see these videos to help them pass their GCSEs, and you doing your bit can help them see these videos to get there. Alright guys, I'll see you in the next video.